Here in this video, we are solving two simple questions from AIPMT from the chapter waves. Let's have a look at the first question. A transverse wave is represented by given a sin omega t minus kx. What's the value of the wavelength is the wave, for what value of the wavelength is the wave velocity equal to the maximum particle velocity, right? So first of all, I shall be able to write what is the wave velocity and maximum particle velocity is given the displacement y equal to a sin omega t minus kx, where a is amplitude, omega is rate of change of angular displacement, that is 2 pi by t, that is 2 pi into n, where n is the frequency. K is a constant called phase constant whose value is 2 pi by lambda. So when you make omega by k, it becomes 2 pi n by 2 pi by lambda. It becomes n lambda, that is equal to v. So in a given equation, we can write wave velocity v as omega by k. We can also write velocity of particle in SHM, in oscillatory motion, v as omega into root of a square minus y square. If y equal to 0, v becomes maximum. That implies I can write v maximum equal to omega into root of a square minus 0 square, omega into square root of a square equal to omega a. So what he's saying in the problem is, for what value of wavelength lambda, wave velocity equal to maximum particle velocity. I know the equation for wave velocity. I know the equation for maximum particle velocity. Let's equate them. That implies if when wave velocity equal to maximum particle velocity, wave velocity is omega by k, maximum particle velocity is omega a. Omega cancels. 1 by, as I told you, k is 2 pi by lambda equal to a. So lambda by 2 pi equal to a. So wavelength lambda equal to 2 pi into a, which is the answer for the problem. We want wavelength in the problem. This is all the first problem itself. What all I have solved is only the first problem. Now let's have a look at the second problem that we are having. It is given that a transverse wave is propagating along x-axis represented by this equation. All regular things, right? See, the equation is again in the same format. Y equal to a sin omega t minus kx plus or minus some initial value, some constant is given for you, some constant, some phi you can say, some whatever it is, initial phase. R to be equal to a sin kx omega minus omega t minus phi. So in this case, as I have derived, wave velocity equation we have already derived. So as we have shown, wave velocity v equal to omega by k, right? So what is there in the place of omega? Omega is product of 2t. So for the t, the product here is 2 pi. So omega equal to 4 pi in the problem. K is product of x, that is 0.5 pi. So pi and pi will cancel. 4 by 0.5. 0.5 is half. 4 into 2 is 8 meter per second. So answer for the problem is 8 meter per second. So I mean to tell you that we have already derived this velocity equation here in this video. That's why we have in the previous question. That's why we are solving these two problems together, so that it will be easy to connect and do it together, right? Thanks for watching.